Electromeric effect in organic chemistry. In this lecture, I will teach you my personal trick of positive E effect and negative E effect. Also, you will learn the type of electromeric effect and uses of electromeric effect. So watch this lecture till the end and you will learn something awesome. Firstly, let me teach you the basic concept of electromeric effect. Consider the sleeping dog. Now let it hears the sound of a cat. The sleeping dog will instantly wake up. There are 100% chances that the dog will attack on the cat. Now consider the opposite case. If there is no sound of a cat, the dog will enjoy his sleeping period. Similarly, consider this alkene. Let I place attacking reagent near this alkene. Now this alkene will wake up and it will change its structure like a dog. Secondly, consider the opposite case. If there is no attacking reagent, this alkene will enjoy its sleeping period. Thus we say that this waking up of alkene in the presence of attacking reagent is known as electromeric effect. Let me repeat it. This waking up of alkene in the presence of attacking reagent is known as electromeric effect. So note it down this easy analogy of electromeric effect. Now what is electromeric effect? Well, consider this alkene which contain a double bond. We already know that one is pi bond and another is sigma bond. Remember that pi bond contains pi electrons and sigma bond contains sigma electrons. Secondly, I place attacking reagent like hydrogen ion in front of it. As a result of this, alkene will wake up, the pi electrons will shift to this carbon, due to which positive charge will appear on this carbon and negative charge will appear on this carbon. Now this alkene becomes instant dipole. There is one positive pole and one negative pole. We call it instant dipole. So we say that this alkene becomes instant dipole due to this attacking reagent. Therefore, we define electromeric effect as the formation of instant dipole due to transfer of pi electrons in the presence of attacking reagent is known as electromeric effect. Let me repeat it. The formation of instant dipole due to transfer of pi electrons in the presence of attacking reagent is known as electromeric effect. Also remember these important points about electromeric effect. It is a temporary effect, it only occurs during chemical reactions. Secondly, it is only observed in pi bond. It doesn't occur in alkane or having single bond. Thirdly, it only occurs in the presence of attacking reagent. Hence note down all these important points. Now let me teach you some examples of electromeric effect. Consider these symmetrical molecules. Now I place attacking reagent in front of them. We know that there is a double bond or pi bond. This double bond contains pi electrons. Now these pi electrons will shift to this carbon. As a result, positive charge will appear on this carbon and a negative charge will appear on this carbon. On the other hand, there is also possibility that these pi electrons will shift to this carbon. Thus, electromeric effect is observed in this organic compound. Secondly, there is also pi electron present in this molecule. Now, these pi electrons will shift to this carbon. As a result, positive charge will appear on this carbon and negative charge will appear on this carbon. On the other hand, there is also possibility that these pi electrons will shift to this carbon. Thus, electromeric effect is observed in this organic compound. Now consider these unsymmetrical organic compounds. We can see that there is a double bond which contain pi electrons. Here in this compound, oxygen is present. We know that oxygen is highly electronegative atom. It will strongly pull the shear paired of electrons. Hence, the pi electrons will shift to oxygen atom. As a result, positive charge will appear on carbon and negative charge appears on oxygen. Remember that in this organic compound, you cannot shift pi electrons toward carbon because electronegative atom oxygen is present. Thus, electromeric effect is observed in this organic compound. Secondly, in this organic compound, nitrogen is highly electronegative atom. It will pull the pi electrons towards itself. As a result, positive charge will appear on carbon and negative charge will appear on nitrogen. Thus, electromeric effect is observed. Thirdly, in this compound, there is alkyl group CH3. We know that it is electrons donating group. Hence, pi electrons will shift in this direction to this carbon. Positive charge appears on this carbon and negative charge appears on this carbon. Thus, electromeric effect is observed in it. Hence, these are the different examples of electromeric effect. Now, let me teach you the types of electromeric effect. Well, there are two types of electromeric effect: positive electromeric effect and negative electromeric effect. Here, let me teach you my personal trick to remember positive and negative electromeric effect. If pi electrons and attacking reagents are at the same site, it is called as positive electromeric effect. If pi electrons and attacking reagents are at different sites, it is known as negative electromeric effect. Now consider this organic compound and this attacking reagent. The pi electrons will shift to this oxygen. Positive charge appears on this carbon and negative charge appears on this oxygen. Here, let me ask you, where this attacking reagent will attack? Well, the easy trick is negative and positive attracts. This positive hydrogen will attack on this negative carbon. Thus, we get this organic compound. Now listen carefully. Here, pi electrons shift to this oxygen and the reagent also attack on this oxygen. I mean, pi electrons and attacking reagents are at the same site. Thus, we call it positive electromeric effect. On the other hand, consider this case. We know that these pi electrons will shift to this oxygen, positive charge appears on this carbon and negative charge appears on this oxygen. Here, let me ask you, where this attacking reagent will attack? Well, we already know the trick. Positive and negative attracts. Hence, this ion will be attached to this positive carbon. We get this organic compound. Now listen carefully. Here, pi electrons shift to this oxygen, but the reagent CN doesn't attack on the oxygen. Rather, it attacks on the opposite side. I mean, pi electrons and attacking reagents are at different site. Thus, we call it negative electromeric effect. These are the two types of electromeric effect. Finally, let me teach you the application of electromeric effect. Well, electromeric effect helps us to determine the product of any chemical reaction. For example, consider this chemical reaction. We know that this compound contains double bond where pi electrons are present. These pi electrons shift to this carbon and opposite charge appears on each carbon. Secondly, this hydrogen fluoride contains two attacking reagents. Hydrogen is a positive attacking reagent and fluorine is a negative attacking reagent. Now this positive hydrogen will attack on this negative carbon, while this negative fluorine will attack on this positive carbon. As a result, we get this organic compound. Secondly, consider this reaction. Pause the video and try to solve it. Well, we know that nitrogen is a highly electronegative atom. It will attract pi electrons strongly. Secondly, hydrogen is a positive species and hydroxide is a negative species. Now this positive hydrogen will attack on this negative nitrogen. This negative hydroxide will attack on this positive carbon. As a result, we get this organic compound. Thus using electromeric effect, we can easily determine the products of any chemical reaction. I hope that you have learned all about electromeric effect.